Hello, Vanakkam, Namaste, and welcome to Problem Solving for Effective Mathematics Teaching and Learning. I'm Dr. Jayanti from Experiential Math Solutions. In my last video, I explained how to introduce in mathematical investigations to younger students. In this video, we will discuss more challenging questions. Let us look at one of the traditional investigations, finding relationship between non-collinear points and the lines connecting them. In our first figure, there is only one point, and hence we cannot draw any line. In the second figure, there are 2 points, and one line can connect them. In the third figure, there are 3 non-collinear points. That means they do not lie on the same straight line. So 3 lines can be drawn connecting all the 3 points. We can ask the students to plot 4 non-collinear points and find the number of lines connecting all these 4 points. And then we can ask them to tabulate their findings and find a relationship between the number of points and the lines connecting them. Ask them to represent L, the number of lines connecting the non-collinear points, in terms of N, the number of non-collinear points. We can ask the students to present their findings in a table like this. When n is equal to 1, the number of lines, connecting lines, will be 0. N is equal to 2, 1, L is 1. N is equal to 3, L is equal to 3. N is equal to 4, L is equal to 6. Now the students can see the pattern. From 0 to 1, there is an increase of 1. 1 to 3 means there is an increase of 2. 3 to 6, an increase of 3. That means when n is equal to 5, without drawing figure, they can find that the number of connecting lines when there are 5 non-collinear points, it should be 10, because the 6 plus 4 is equal to 10. Now students can see the pattern again. How to find when n is equal to 10, what will be the number of connecting lines without drawing the figures. 3 can be represented as 1 plus 2. 6 can be represented as 1 plus 2 plus 3. So 10 will be 1 plus 2 plus 3 plus 4. So when n is equal to 10, it should be 1 plus 2 plus 3 plus 4 plus up to 9 will be, the sum of 1 to 9 will be the number of lines connecting 10 non-collinear points. Similarly, that can be extended to general formula. When there are n number of points, the number of connecting lines will be the sum of 1 to n minus 1, which can be represented as half into n minus 1. Now we can see another investigation, finding the number of diagonals of a polygon. First, a student should know what is a diagonal. It's a line segment joining any 2 non-adjacent vertices. So now in a triangle, there is no non-adjacent vertex. So there will be no diagonal for a triangle. For a quadrilateral, in here I have drawn a parallelogram. There are 4 sides. You can draw 2 diagonals. For a pentagon, the number of diagonals will be 5. Now, the question is to find a relation between the number of sides of a polygon and its diagonals. Again, we can ask students to tabulate their results in a table. When n is equal to 3, D diagonal is 0. When n is equal to 4, D is equal to 2, n is equal to 5, D is equal to 5. So what will be when n is equal to 6? For a hexagon, what will be the number of diagonals? Or for a heptagon, what will be the number of diagonals? And if it is a 20-sided polygon, following the pattern, how will you find the number of diagonals? For a pentagon, we know that the number of diagonal is 5. So it's in increase 2 plus 3. The previous one for a parallelogram we saw, or any quadrilateral, we saw the number of diagonal is 2. So n is equal to 6. It should be 2 plus 3 plus 4. For 7, it should be 2 plus 3 plus 4 plus 5. Students need not draw the diagonals. When they draw, they may miss out something. So from the pattern, they can find out. So for 20-sided polygon, it should be 2 plus 3 plus 4 plus 5 plus up to 18. For lower form students, they can find the sum. For higher class students like year 8 and 9, we can ask them to generalize the result and find the formula. Another interesting question is the red-faced cubes investigation. A cube of 2 units is painted on outside red and cut into smaller cubes of unit length. How many cubes will have 3 red faces? How many cubes will have 2 red faces? How many cubes will have 1 red face and no red face? Now, 2 units, a cube of 2 units is painted outside red and cut it into smaller cubes of unit length. So all the 8 cubes will have 3 red faces. There will be no 2 red faces and no 1 red face or no red face. Now we extend this to 3 units. A cube of 3 units is painted on the outside red and cut it into smaller cubes of unit length. How many cubes will have 3 red faces? How many cubes will have 2 red faces, 1 red face and no red face? Now in this case, only the cubes at the corner will have 3 red faces. So there will be 8 cubes with 3 red faces, and each face will have 2 cubes with 2 red faces. So 6 into 2, 12 red faces in total they will have. And only each face will have the center one with 1 red face. That means there will be 6 red faces. And only if you imagine the whole 3 by 3 cube, the center cube will have no red face. Only one will have no red face. Now we have to extend this to a cube of 4 units, and then we have to deduce the general formula. We can ask the students to work as a team so that they can seek help from one another. Ask them to present their findings in a table like this so that they can see the pattern clearly. Now, students can find that whatever may be the length of the side, the number of cubes with 3 red faces will be 8. Whereas the number of cubes with 2 red faces when n is equal to, when the length of the side is 2 is 0, 3, 12, 4, 24, 5, 36. There is an increase of 12. So the formula should start with 12 into something. 12 into 0, 12 into 1, 12 into 2, 12 into 3. From this they can find the general formula as 12 into n minus 2. The number of cubes with 1 red face, 0, 6, 24, 54. So 6 into 0, 6 into 1, 6 into 4, 6 into 9. 1, 4, 9 are square numbers. So the general formula you can find from this pattern. On the other hand, the number of cubes with no red faces, 0, 1, 8, 27, 64. 1, 8, 27, 64 are all cube numbers. 1 cube, 2 cube, 3 cube, 4 cube. So the pattern will be n minus 2 the whole cube. Using the pattern they can find the general formula. According to Poisson, life is good for only 2 things: discovering mathematics and teaching mathematics. Enjoy teaching mathematics and let students discover mathematics. Thank you. This is Dr. Jayanti from Experiential Math Solutions. If you want to watch more videos on problem solving, please subscribe our channel. Thank you. Good luck. Stay healthy. Bye for now.